Hello, Algebra 2 students. Today we'll be doing 10.4 notes, find probabilities of disjoint and overlapping events. Here's some probability properties. For any event A, the probability of A is between 0 and 1. That is, the probability of A is greater than or equal to 0 and it's less than or equal to 1. Let's just looking at event A being flipping a coin. So the probability is between 0 and 1, and the probability of flipping a coin and getting it to land heads would be 1/2. That is between 0 and 1. The probability of sample space S is 1, also noted as probability of S equals 1. The probability of disjoint events is equal to the sum of the probability of these events. Now, disjoint events cannot happen at the same time. So if A and B are disjoint, then the probability of A or B is equal to the probability of A plus the probability of B. When you consider all the outcomes for either of two events A and B, you form the union of A and B. And remember, union is the U and it means or. When you consider only the outcome shared by both A and B, you form the intersection of A and B, and intersection is the upside down U. The union or intersection of two events is called a compound event. So if you look at the diagram below, the union, so figure 1 on the far left, the union of A and B can be whatever is in A or in B or in both. Whereas in figure number 2, the intersection is that pink region in the center where you have 4 dots in common. And then finally, in picture number 3, that's null. That's the intersection of A and B is empty. So that example right there, the diagram 3 is disjoint events, two events that cannot occur at the same time. Okay, that leads us to that definition again. So disjoint events are events which cannot occur at the same time. Okay. Well, I wanted to point out that actually look at figure number 1. For overlapping events, I think I wrote the figure number. Yeah, I did. For this one, I meant 3. And then for the overlapping, I wanted you to look at 2. Yeah. So go ahead and fix that. So overlapping events which have one or more outcomes in common. There we go. And that would be figure 2. So let's do a couple of examples with the Venn diagram. So example 1 has two events A and B. Event A is wearing a hat and there's 12 individuals. Event B, attending school, 11 individuals. And then there's 3 that's outside both. So that's neither an event A or an event B. And S just tells you that's their whole sample space. In part A, so let's count up how many we have total. So 12 plus 11 plus 3, that would be 26 total. We'll just say students, I guess, because they're attending school. So in A, we are asked to find the probability. Again, you have to know what this means. And that means not in A or not A. So what's the probability that it's not A? Well, if it's not A, then it has to be in B or not. So if it's not in A, it's everything other than A. So everything other than A is the one in are the students in B and the ones that are neither A nor B. So add those probabilities together and you get 14 out of 26, which as a decimal, is about 0.538. And as a percent, that's almost 54%. So that's quite a bit, more than half. Okay, on part B, find the probability of A or B. So again, remember, figure out which one you want to memorize and you know the other one. So and if it helps you, you might want to write it like this. You totally can. So the probability of A or B would be the probability of A plus the probability of B. So that would be 12 out of 26 plus 11 out of 26, which is 23 out of 26. And you can leave it like that, or you can write it as a decimal. That would be 0.885. And most students never write it as a percent. Why do more than you have to? But that is 88.5%. Okay. Okay, example number 2. We have event A, answer all questions, and event B, score well on a test. So in this particular case, there is something in common. So let's go ahead and figure out how many total students there are. So we have 5 plus 10 plus 2 plus 8. So that would be 25 altogether. Okay, and in part A, what's the probability of A and B? Okay. So A and B would be the intersection. So the probability of A and B is 10 out of 25. This region right here. And let's reduce our fractions. We always should. So divide top and bottom by 5. So it'd be 2/5, which as a decimal is 40%. For some students, probabilities, the numbers make more sense when it's a decimal or a percent. Okay. For part B, find the probability of A or B. So the probability of A or B is equal to the probability of A plus the probability of B minus, you're probably thinking, where is she getting this? The probability of A and B. Here's where I'm getting this. Anytime you have an overlap, you have to subtract it because you don't want to double count. So the probability of A is 5 plus 10 is 15 out of 25. The probability of B is 10 plus 2, which is 12 out of 25. And notice we double counted. We can't double count. We included 10 in both of those groups. So we have to subtract what they both have in common. So we want to subtract the 10 out of 25, and that'll give you the probability of A or B. So the probability of A or B is equal to, combine the numerator, so 15 plus 12, 27, minus 10, 17 out of 25, which happens to be 68%. And that is the first page of notes. That last problem B will lead us up to our formulas for this section, and it's called the addition rule. If A and B are any two events, then the probability of A or B, so the probability, again, or, is equal to the probability of A plus the probability of B minus the probability of A and B. Put and here. And so remember, this is the intersection that's where the outcomes in common. Right. If A and B are disjoint, so they can't happen at the same time, it also means mutually exclusive, then the probability of A or B is, so the formula just changes up a little bit. So again, is equal to the probability of A plus the probability of B minus 0. And the reason why it's 0 is because if they're disjoint, they don't have anything in common, nothing shared. So no shared outcomes. And those are your formulas. So honestly, I would remember the top one and just know if it's disjoint, if they don't have nothing in common, it's going to be just adding the individual probabilities together and just leaving out the and portion. But we'll do several examples. First one, a six-sided die is rolled. What is the probability that the number rolled is less than 3? So we can call the number rolled less than 3 as event A, and event B can be or greater than 5. So if it's going to be a number less than 3, then it can only be 1 or 2 because it's a six-sided die. If it's greater than 5, the number is going to be 6. So notice they have nothing in common. Those are three distinct numbers. So no outcomes in common. So the probability of A plus the probability of B minus 0 is the one that we are going to use. So to find the probability of event A or B, you're going to add the probability of A, which is 2 out of 6, because remember, it's a six-sided die, so 6 numbers. Only 2 of them, 1 and 2, are less than 3, plus the probability of event B, 1 number out of 6. And add those together, you get 3/6, which is equal to 1/2, which we know is 0.5. Right, next problem. We'll go into cards, and there's several of these. A card is randomly selected from a standard deck of 52 cards. So going back to cards, a little refresher. We have 4 suits, so we have 13 hearts, 13 diamonds, and I'm not even going to bother drawing spades. So 13 spades, 13 clubs. Okay. And so that's kind of a really good starting point there. So part A, selecting an ace or an 8. So you can draw pictures, you can draw a Venn diagram, whatever helps you. Sometimes I just like write them out. So I know there's an ace of hearts, there's an ace of diamonds, there's an ace of spades, ace of clubs. An 8 is going to be an 8 of hearts, 8 of diamonds, 8 of spades, 8 of clubs. I don't know why I wrote that so far apart, but that's okay. I'll find a little bit of room. So notice they have no outcomes in common. So we are going to use the top formula, or I'm sorry, the bottom formula. So we're just going to add the individual probabilities. So the probability of A or B, maybe I can fit it in here, down here, since I wrote so big. So the probability of A or B, and we can say selecting an ace was event A and selecting an 8 event B. So that would be 4 out of 52 cards are aces, plus 4 out of 52 cards are 8s. Adding those together, you get 8 out of 52, which I reduce to 2/13. And I'm not going to bother with a decimal, but it is about 0.154, so 15.4%. Okay, let's do B. Selecting a 10 or a diamond. This time I won't draw big, and I'll draw a Venn diagram just to change it up a little. Okay, so you have 4 10s. So you have a 10 of hearts, 10 of diamond, or I'm sorry, because there's going to be a 10 of diamonds. So a 10 of clubs, 10 spades. You know we have 13 total diamonds. One of them will be a 10 of diamonds. But then there'll be 12 other cards. or 12 other diamonds. It's a really bad diamond. So so they do have an outcome in common, and that outcome in common is this 10 of diamonds. So to find the probability of A or B is equal to the probability of A plus the probability of B minus the probability of both A and B. I'll just put the word and. Okay, so the probability of A, selecting a 10 can be A, diamond could be B, is 4 out of 52. Probability of B is 13 out of 52. There are 13 diamonds in a deck, minus the one card that they have in common. So this is the 10 of diamonds. Okay. And so combining those numerators, so you have 17 minus 1, you have 16 out of 52, which reduces to 4/13. Great. Moving along to C, selecting a 10 and a diamond. Well, that kind of answers our question. B answers our question. So there is only one card, which is a 10 and a diamond. So the probability is 1 out of 52. Okay, next one, D, selecting an ace and an 8. Well, look at part A. A card is randomly selected. You can't select an ace and an 8 at the same time. So the probability is 0 out of 52, which is 0%. 0. And the last one for the cards, selecting a queen or a club. So you have a queen of hearts, queen of diamonds, queen of spades, and a queen of clubs. B. A club, you have a queen of clubs plus 12 other clubs. You have an ace, a jack, a king, a 2, a 3, so on. So they do have this shared outcome in common. So this is the exact same problem as problem B, and it's going to give us 4 out of 52. So we'll go ahead and set it up. So probability of A or B equals probability of A, 4 out of 52 queens, plus B, 13 out of 52 clubs, minus the queen of clubs. So that's 16 over 52, which is 4/13. Okay. Our last question. Okay. Of 100 students surveyed, 92 own either a car or a computer. Also, 65 own cars and 82 own computers. What is the probability that a randomly selected student owns both a car and a computer? So for this one, let's look at the first sentence. Of 100 students surveyed, 92 own either a car or a computer. Okay, so that's going to be our left side of our equation. Also, 65 own cars, so that can be an event, and 82 own computers, the other event. So now we can write our equation. So probability of A or B is equal to the probability of just A plus the probability of just B minus the probability of A and B. Oops. Oh, I just want to use that kind of notation. But you don't have to. You can use the words and or if you want to as well. So our question is, what's the probability that a randomly selected student owns both a car and a computer? So the giveaway that we are going to solve for the and portion is the word and. So we know the left side of our equation is 92 over 100. Probability is a fraction. And the probability of A is 65 over 100. B is 82 over 100. That's the computers. But we don't know this. We're going to find that. So just call it a variable. And then I'm going to add like terms. So we have 92 over 100 on the left. 65 plus 82 is 147 over 100 minus x. Okay. Now some students don't like the negative x, so they want to add it to both sides, and that's probably a wise idea. So we have x plus 92 over 100 equals 147 over 100. Now subtract 92 over 100 on both sides. And we have x equals 55 over 100, which is our probability. So the probability of A and B is equal to 55 over 100, which as a decimal is 0.55. Now, some students say, Mrs. Hess, I can do this problem a different way because it'll make more sense to me. By all means, this is how I would have done it. Just my brain thinks better certain ways, so I would have done a two-way table. Now, I don't know if any of you were thinking about that. So let's just do a two-way table. It's a really good refresher. So event A was having a car. Event B was owning a computer. So then this row would be not a car. This column would be not a computer. Okay, let's see. Of 100, and we have 100 students total, so 100 goes here. Of 100 students surveyed, 92 own either a car or a computer. Also, 65 own cars. 65 own just all cars, and 82 own just computers. Therefore, this must be 18 because 82 plus 18 adds up to 100, and this must be 35. Okay. If 92 owned at least one of those, a car or a computer, 8 people owned nothing because there's 100 people surveyed. So 8 goes right here. And there's just a process of filling in the rest of the table. So this has to be 27. 27 plus 8 is 35. And then this has to be 55 because 55 plus 27 is 82. And this is 10. Here is our answer. So much faster. 55 people own both a car and a computer. And so you could have done it that way, whatever way your mind can process the problem better. And those are your notes for today. Have a great day, Algebra 2 students.